I hope the screen is visible to all. Hello.
Yes, ma'am.
Okay. We will go ahead. So we will be dealing with the various online tools which are available for free for thermal comfort assessments. So let me begin with the same question again. What data is essential for thermal comfort assessment? Whatever comes to your mind, please drop it in the chat box. What all data are required for assessing thermal comfort? It can be wrong or right, it doesn't matter. Just write whatever you feel is required to assess whether you are thermally comfortable. Am I audible?
Yes, ma'am, audible.
Yeah. Temperature, humidity, okay. What else? Fresh air, activity, relative humidity, yes. Humidity, ventilation, temperature, okay. Dew point, precipitation, okay. Surface temperature, clothing level, okay. Whatever was told till now was the environmental parameters. Clothing level is a personal parameter. Then activity level is also a personal parameter. Okay. So when you want to assess the comfort of a person, all these are relevant parameters. But where do you get this data from? You cannot go and measure everything. Maybe temperature, humidity and airspeed, maybe you can measure at that particular point for getting us while doing a survey to see whether a person is comfortable or not. But most of the time what we do is we try to simulate the all possible scenarios. So when you do the simulation of possible scenarios, we need the weather data of any particular place. That will have all these parameters except the personal variables like clothing and activity. This airspeed, solar radiation, temperature, humidity, all these things will be given in the weather data for a particular location. So now I mentioned just weather data. But where do you get the weather data and how do you differentiate between weather and climate? What is the difference between weather and climate? Are both same? Yes or no, please? Is weather and climate same?
No, it's not same.
Yeah, it's not the same. Climate is a long-term data, whereas weather is a temporal data. So this gives a quick overview. Weather can change within minutes or hours. Now it may be sunny now, but the weather keeps changing. Whereas climate is the average weather recorded in a specific place over a period, a long period. So as per NBC, National Building Code, how many climate zones are there in India? 5. We have 5 climate zones, which are hot, dry, warm, humid, composite, temperate or moderate, and then cold. So this is a climate zone map as given in the National Building Code. So here you can see, for example, Tamil Nadu is majorly warm humid, but there is a spot of cold climate in between that. And then Maharashtra again is a mix of hot, dry and warm humid, but again there is some cold zone. Again Karnataka has majorly warm humid, but there are some temperate zones where Bangalore and all belong to, and then there are some cold zones which is mostly Coorg area. So these are some basic data which gives an overview on how do we want our built environment to be. The comfort or how we want the built environment to be is largely dependent on the climate of the region. So when you want to be comfortable in Jaipur or in Patna is different from the strategies you would adopt to be comfortable in Kerala or Tamil Nadu, because it is dependent on the climate zone. So let us see, for all these, what do we need? We need the weather data. Weather data gives the periodic data over a large period of time for simulation purpose. It is either in the form of EPW format or WEA format. Those are two formats. You don't have to worry much about the format, but it is called as weather file. So where do we get the weather file from? I'm sure if anyone has done any kind of simulation, you would have downloaded the weather data. Can you tell where do you download the weather data? Has anyone attempted any simulation? Meteorological Survey of India. You may get some data from there, but it is not free and it is not generally used for the simulation unless you want it for a specific location which is not available else. IMD has the data. The weather file what we are talking is easily available or freely available from two websites basically. One is the Energy Plus website where you can download the weather file. I will redirect you to that website now where can you see the screen now where I'm at the weather data? So this was the old website where you used to get the weather data. So here you can go to Asia, then India or whichever city you want. But one thing you would see is there are not many cities given here. Like for example, if you take Kerala, you have only one city from Kerala here, Trivandrum. No other cities are given here. There are some other website. There is one another important website which someone has already mentioned in the chat. Here, it's onebuilding.org. It's climate.onebuilding.org. So here you will get the weather data for almost everywhere. So here you can go again, Asia. Here you can go to India. Then for different states, it is categorized. For any state or whichever area you want, you will have multiple weather files. The case which I was telling as example was Kerala, where you had only Trivandrum. But here there are multiple cities now. You can take the nearest city which you think is having the same climate. I will share the link of these also in the chat. You can take 5 minutes, explore this, and then we will go forward. Let me know if you have any difficulty in accessing these websites. Okay, so here it is telling for Agra there are 4 options, which one to take. See, you can see along with that the year 2004 to 2018, 2007 to 2021. So this data gives the average over that period. So when you see, if you want to consider the latest weather changes within the climate, you can take the updated one, the latest one, which is 2009 to 2023, which is over a larger period. Yes, in Energy Plus it has limited locations, whereas onebuilding.org has more options. Most of the places when there is an airport or when there is a weather station located, that data is given here in the onebuilding.org. Energy Plus has very limited data. But that used to be the most prominent site. I didn't get the question. So will we decide similar to the climatic condition? I didn't get the question. Can you repeat it again? If you don't have the location for which you don't have the data, you don't have to go in Energy Plus, then go for onebuilding.org. Here you may get most probably the most nearest location at least. Any other doubts or difficulties? If not, shall I go forward? Okay. So these are two websites where we can download the weather data for any simulation purpose. And now if you want to if you want to visualize the weather data, so this is another website where I will be again sharing. If you want to see how much is the like a graph or some other data, this is again another online tool which is developed by University of Berkeley. See, all these blue dots in the world map represents that the weather data is available for that region. So we can just pan the mouse and you can see for India all these places have the weather data available. You can choose any place. Click on any place you are interested in. So I have now randomly clicked Bellary. It is a city in Karnataka. So once you click on that, the weather data from that region would be generated here. So the EPW was successfully loaded is shown here. And then you can go to the next page where there is climate summary. On the top, the second tab is the climate summary where you get the summary of the region. And also you can see in the map where it is. So the latitude and longitude of the place is given and the climate classification as per the Köppen zone is given. And then the average yearly temperature is 26.9. Hottest yearly temperature is 38.2 and the coldest yearly temperature is 17.7. So here you get only the average data as a summary. If you want to see more detailed graphics, you have multiple options here and you can try exploring these. And then you can, if you are only interested in the temperature and humidity, go to the next one, temperature and humidity, where the dry bulb temperature is the variable here. I hope you can see my screen. It's visible, right? Yeah. So here the dry bulb temperature is the selected variable now. So it's the yearly chart from January to December. How is the dry bulb temperature varying? And here again, the line shows the average one. The bold line shows the average one. The red one is the range. From what temperature to what temperature it is changing. And again, there is a gray chart or the gray line is there behind. The legend shows it is ASHRAE adaptive comfort. ASHRAE gives the adaptive comfort range where adaptive comfort 80% means in this temperature range 80% of the people think it is comfortable or 80% of the people respond as comfortable. So when you take this particular place, you can see a large number of people or a large temperature range goes above this ASHRAE adaptive comfort 80%. So that means during this time it's not comfortable, especially from mid of February to June beginning, it is extremely hot. The temperature range is way beyond the ASHRAE adaptive comfort range. Understood? So similarly, what you can do is you can take the climate of your region or any place near to you so that it makes it easy for you to relate the temperature or relate the weather of the region. Someone who has never seen or never heard of Bellary may not be able to relate the range there. Suppose if you are from Delhi or if you are from Nagpur, and if you take that climate, then you will get a better understanding. We'll do one thing. This is very easy to locate the climate here from the map. Go to the link which I shared in the chat before, the one which I shared last. Take the place where you are from or the place nearby. Take it till here, temperature and humidity. Sorry? Is anyone asking something? Hello?
No, ma'am. No, ma'am. Please continue.
Okay. So you can take the place nearby, choose it from the map, and see the yearly chart of dry bulb temperature. I'll give you 5 minutes. You can explore it. Meanwhile, if you find any difficulty, just let me know. This is the link I'm mentioning here above. You can share it again.
The other charts like daily chart, heat map chart, which things below this graph.
Yeah. What is the question? I didn't get.
Like, what is the purpose of these charts now analysis?
See, this is the first one is a very elongated one where you get a comprehensive understanding. If you want to specifically analyze for a specific month, then you can use this. See here, the first one is January. So in January, the bottom one is the number of days. So this day at this time, it is this temperature. This is the average temperature. What does color by mean? Color by meaning? The light below selection option. Can you unmute and ask yourself? I'm not understanding your query. Are you asking the heat map chart? This one? Okay, psychrometric chart is I haven't reached yet there. I will show you. So has everyone else reached till here? And here in the heat map chart, you can clearly see there is a legend on the right side where it ranges from 10 to 45.
Hello.
So, hello.
Yeah, ma'am. Can we add some new points in this map?
Yes.
And blue points is already given in this map. How we can add a new location?
No, we cannot add new location here because this is based on the weather data. Weather data means when you have a weather station, the weather data or weather file takes the average of a long-term periodic weather data which is monitored or measured. So unless you have a weather station there where you have been continuously monitoring for an year at least, you cannot add a weather file.
So
That
the
the question?
location are given, that's location specific already given. So we can study on only on this location.
If you have certain institutes have their own weather stations which may not be given into this. So if you have such a weather station in your institute where you have the data, then you can
Yes.
make it as a weather file.
Okay, okay.
Oh. So here in this heat map chart, as we saw here already above, a large portion of February to May is very hot. So that is seen here, the orangish yellow indicates that around this time it is so hot. It may not be comfortable. And then when you go to the other parameters like sun and clouds, you get to see the sun path diagram. What are the solar radiation, horizontal and diffuse and global solar radiation? What is the wind data? How is the annual wind rose diagram? The wind direction is primarily from the west side, which is at a higher intensity, and there are some winds from the east, southeast winds also. And then you have psychrometric chart where you can get to know what variable you want to see. Suppose if you want to see the dry bulb temperature, here you can see it based on different parameters. Like for different temperature, what would be the psychrometric chart is a little more complex theory or complex thing which would be very difficult to deal in detail here. Those who are interested may contact me later. I will explain to you in a later session soon. Because as part of this itself will take an hour or so to explain it very clearly. And then for natural ventilation, what are the possible times when natural ventilation is feasible? And then what is the outdoor temperature data? UTCI is Universal Thermal Comfort Index, where outdoor comfort is measured. UTCI is a metrics which gives you an idea on the thermal comfort outdoors. Whereas whatever we do, whatever analysis you do inside, like adaptive comfort or PPD, PMV, all those things are for the interior spaces. And then there is something called Data Explorer where you can generate data for different parameters. Temperature, dry bulb temperature, wet bulb temperature, relative humidity, all these data. So now what we have done is, we know that for any comfort analysis, when we do any simulation, the basic data what we require is the weather data. So for weather data, we can get it from multiple sources. One can be from the Energy Plus website, or it can be from the onebuilding.org website. And there are multiple ways of visualizing the weather data. This is one online tool where you can visualize it. And then there is another tool which is offline and which is free, where it is called as Climate Consultant. Has anyone heard of Climate Consultant? Yes or no, please? Yeah. Those who have heard would be knowing that it's very easy to use. For those who have not heard, for them, I'm just sharing the website here. And There you will get to download it very freely. It's not heavy file also. It's just 61 MB file. Maybe you can keep it for download. Those who have not used it here, maybe at the end of the session, I will open it and show how it can be used for those who have not heard of it. Based on your version, whether it's Windows or Mac, you can download the compatible version. We'll see it at the end. The CBE, the Clamor tool is free. It is an online interface. It's not a downloadable software. So similarly, there is another one again by CBE itself. You can do a Google search, CBE thermal comfort tool. And in this CBE thermal comfort tool, I will share the link again. You can just Google CBE thermal comfort tool. It will show the first link itself. I'll share this link again in the chat. So this is something which I want all of you to explore. Take up this website, and once this page has come, let me know. I'll go forward after that only. This is very important and very useful tool for any thermal comfort assessment online. Okay, someone was asking, can you specify which year this chart represents and whether it's based? It is not representing any specific year. That is the weather data which gives an average over a long period of time. It is not specific to a particular year. So in this CBE thermal comfort tool, you can see there are different methods. The first one is ASHRAE 55, which is the adaptive comfort model, which is more relevant to any naturally air-conditioned naturally ventilated space. So here again, there are two methods, PMV method and the adaptive method. Let us first see the PMV method. So here, this is dependent on a large number of parameters. So suppose your operative temperature or the temperature at which you are there now is 25 degrees, or let us see it as 27 degrees. So the moment you increase or decrease the temperature, you can see there is a change in the red dot and the circle here on the right side. Can you see it? There is a red circle with a dot.
Yes, sir.
So when the temperature is increased, when it is 27 degree, it is outside this blue band, where top you will get an alert telling that it doesn't comply with ASHRAE standard 55 2023. That means it is hot here. But what can we do? Now the airspeed is only 0.1. Let us try increasing the airspeed. What if we increase the airspeed? If we increase the airspeed to 0.2 or 0.3, it complies. It is in the comfort zone. So even if the temperature is getting increased at 50% relative humidity, if the airspeed is increased, you can still be comfortable. Again, this is for metabolic rate 1. That means you are seated quietly. You are sitting on a table with some normal work. Then the metabolism of your body would be equivalent to 1 metabolic rate, 1 met, with which you are comfortable. Suppose for the same condition, if you are cooking, see, you are towards the outside range, not yet completely outside, but towards an outside range. Or if you are doing some machine work or light machine work, you are outside the comfortable zone. So in the beginning, I had asked what all things may affect the thermal comfort. So this screen gives an overall idea of it. The temperature, airspeed, relative humidity, metabolic rate, which indicates how much physical activity we are involved in, and the clothing level, like how much clothed we are. So here, this light machine work gives us that it is not comfortable. So let us go back again to the seating or reading seated. We are in the comfort level. Again, let us see the clothing level details. So here there is again one arrow. If you are in this typical summer indoor clothing, or if you are in a jacket, trousers and long sleeve shirt, it is increased. So again, you are uncomfortable. So the clothing levels are identified, or the values are calculated based on how much body is clothed with. These are basically done with laboratory measurements for typical clothing as assembles. So for the same thing, we are again sitting only. But if you are wearing jacket, trousers and a long sleeve shirt, you are still uncomfortable. But if you are in a typical summer indoor clothing, you are comfortable. So all these factors affects the comfort conditions which you are in. And for here we have given the relative humidity as 50%. But in a warm humid area, 50 is very less. It might be quite high. It might even go to 70, 77. So let it be 80%. Even at the 80%, it is comfortable if you have this 0.3 as the airspeed. If the airspeed is 0.2 or 0.1, you are not comfortable. Even with the light indoor clothing, when you are reading seated, when the airspeed is low, if the humidity is higher, you are not comfortable. So when the humidity is higher, it is preferred to have more airflow, where your humidity or your sweat gets absorbed or the sweat get removed from the body, which makes you more comfortable. So if you increase the airspeed here, you get it comfortable. Do you have any doubts yet? Okay. Now, what I want you to do is, this is a hands-on session. You may not be knowing what is the operative temperature you are at right now, but assume your temperature, humidity and airspeed. Consider your clothing level as such with the exact metabolic rate and try populating your comfort condition for your existing condition. You can take 5 to 10 minutes. Let me know after you have done it. And in the chat, type the PMV. There is one value here, PMV, with elevated airspeed, or when there is lesser airspeed, it may be just PMV. So what is the PMV value you are getting? Just type it here.
And this operative temperature means indoor temperature or out?
It is the indoor. At what temperature is the room operating? That considers if you have some machineries or if you have some radiating equipments inside, that temperature is also included in this.
Okay.
As you are done, type in the PMV values. Okay, is anyone else doing?
Ma'am, we are already writing the chat box some participants. Please cross check.
Yeah. Okay. So here you can see at the bottom, there is something written called limits of applicability. So this standard is applicable only to healthy individuals. And this standard does not apply to occupants whose clothing insulation exceed 1.5 kilo, which is not very common. Then whose clothing is highly impermeable, or who are sleeping, reclining in contact with bedding, or able to adjust blankets or bedding. So especially if you are in a bed where there will be a huge insulation associated with this, then the clothing value doesn't seem sensible. So it cannot be applicable in that conditions. And again, for all the details regarding to what goes behind this calculation, there is something called as documentation here below. In the bottom, there is something called as documentation. When you click on that, you will get all the details on how these things on the user interface, what are the outputs and how are these being calculated. Even the PMV, how is it calculated, what is adaptive method, what are the additional features associated with this. You can explore these things from the tab of documentation from this window. Now let us see another method. Here we have done PMV method. So PMV method, the problem is it is majorly applicable for air conditioned spaces, or the PPD PMV model was developed by Franco Gehry for conditioned spaces. There is something called as adaptive method, where when you get exposed to a particular temperature and humidity, you get adapted to it to a larger range. So for that, let us see if the outdoor, it is very simple. When the operative temperature is 27 degrees Celsius and the mean outdoor temperature, it is dependent on the mean outdoor temperature. You can click on it where you will get to know what is meant by mean outdoor temperature. So here, if the outdoor temperature is 30 degree or 32 degree, the indoor temperature, even if it is 30 degree, you will feel comfortable. 80% of the people will feel comfortable up to 31.2 degrees Celsius when the outdoor temperature is 32 degrees. Again, this is without considering an airspeed. So if there is an airspeed of 0.3 meter per second, it is like this. And if there is an elevated airspeed of 0.6 meter per second, you get comfortable even up to 32.4 degrees Celsius. So the outdoor temperature, if it is 32 and indoor is 32.4, it's higher than outside. Still you will feel comfortable when there is an airspeed. If the airspeed is 1.2 meter per second, you can feel comfortable up to 33.4 degrees Celsius. So, but where do you limit the airspeed? In a bedroom, maybe we may give or we may prefer higher airspeeds, but in an office environment or in a work environment, we won't prefer a high airspeed since it might affect or it might make the paper fly. It won't be very comfortable. So similarly, for adaptive method, it is just the outdoor temperature and the indoor temperature and the airspeed which decides whether we are comfortable or not. So here there is an assumption again. The metabolic rates are ranging from 1 to 1.3. The occupants are free to adapt their clothing to their indoor and outdoor thermal condition with a range as wide as 0.5 and 1. Suppose if someone was wearing a jacket and if they feel the outdoor temperature is so high, they are free to remove the jacket. Those kind of clothing adaptations within the range of 0.5 to 1 kilo is assumed to be done in such conditions to calculate the adaptive method. Is it clear?
Yes,
Any
ma'am.
doubts?
How do you consider if, like for indoor, if if it is office space, we prefer like 0 meters per second airspeed speed or what?
Yes, so when the minimum speed in an adaptive environment is 0.3 meter per second. Like that, we are expecting that there will be some ceiling fan or some airflow would be there in a naturally ventilated environment. 0.3 is a very small airflow, which we will barely notice.
No, if it is mechanically ventilated.
This is not for mechanically ventilated spaces. See here, bottom, it is written, method is applicable only for occupant controlled, naturally conditioned spaces that meet all of the following criteria. There is no mechanical cooling system installed. So if there is a mechanical cooling system installed, it's better you go for the PMB method.
No, I mean mechanically ventilated system, not cooling.
Mechanical, what did you mean by mechanically ventilated system? Fans?
Fans or it's ventilation system, mechanical ventilation system without cooling.
Exhaust fans kind of systems, right?
Yeah, exhaust fans or air flow.
That will have an airspeed, right?
Okay. Okay, thank you.
Any other questions? Okay, then another thing what you can do is you can, if you have certain measurements, then you can even upload that measurements as a Excel file and then you will get the values. Suppose here there is a tab called upload, where if your measurement is in SI units, you can download the SI unit template where I'll show you. So there is a template where with the measurement, if you had the air temperature as this, airspeed as this, relative humidity as this, and metabolic clothing, if you have it for all these values, and then after that, you can upload it, and then you will get the PMB PPD value for all these parameters which you have entered. Otherwise, what you can do is here for each of the case you will have to enter it specifically and then see. But if you have a number of scenarios where you have measured, you can compile everything as a CSV file and upload it here. So this is what we have in the CB thermal comfort tool. Where there is a documentation what we discussed. And then again this has another data where if you want to assess the comfort based on a survey, share this link again. So this gives an idea on how you can possibly assess the comfort of a person by question answer if you don't have a measurement device. So one question is, how do you feel right now? Instead of a 2 yes or no question or cool or hot question, it is always better to have a 5-point or 7-point scale where you can tell it's slightly warm or hot to the hotter side and slightly cool and cold to the colder side. So that gives an idea of how is the environment right now. And then is again, how satisfied are you with the thermal environment right now? So for the same temperature and humidity, certain people may be satisfied, certain may not be. So it is again widely dependent on a number of personal factors. Like it can vary with age, it can vary with gender, it can vary with your expectation. If you expect the space to be very cold, even if the temperature is 24 degrees Celsius, you may tell that it's not comfortable thermal. Because your thermal comfort expectation is 21 degrees or even below that. So such kind of questionnaires give you an idea on the thermal perception. So then again, right now, would you prefer to be cooler without any change or warmer? And right now, would you prefer lesser air movement, no change, or more air movement? Then there may be other optional scale. Right now, do you find this environment comfortable, slightly uncomfortable, uncomfortable, very uncomfortable, extremely uncomfortable? Or do you find the thermal environment acceptable, just acceptable, or just unacceptable? These are all subjective thermal perception surveys which you can conduct in any environment post occupancy or any environment where you think you need to assess the thermal conditions. So, but all these surveys should be ideally supported by instrument measurements. Because for the same temperature, one may feel comfortable, some may tell it's very uncomfortable. So unless you have the values with you, you won't be able to make any sense or any inference out of it to make it productive. And then people won't be able to tell the CLO values. Instead, you will have to give such a similar clothing values which resembles their regional clothing style. So here in India, maybe a sari or a kurta should be added. There are a lot of studies on the clothing values of such things. There are multiple studies by Dr. Madhavi Indrakanti done in the city of Hyderabad, where she had explored the regionalized clothing values for saris and typical Indian clothing styles. And then what activity level are you right now? Whether you are sitting, whether you are walking, whether you are standing, all these will have an effect on the thermal sensation, as we already explained, already explored in the tool online. And then again, what floor is your workspace? If it is at the top floor, where you have direct exposure to outside sun, it will be different. And if it is in the southern direction, again depending on which area. And if you are near a window where there is a lot of glare coming in, or if there is an exterior wall where there is direct solar radiation hitting, it will all make a difference in the thermal sensation if you are assessing it. And then how satisfied are you with the temperature in your workspace? Again, it can be a different range, and if you are not satisfied, there can be a number of other reasons. You may feel the humidity is high, you may feel the air movement is high or low, or there may be direct sun, or there may be, you may be comparing it with someone who is sitting right below the air conditioner, or you may not have an option to control the temperature. All these are some factors which will affect your thermal sensation, rather the thermal perception. So this is a brief overview of what we are seeing right now, and if you are interested, I will go into the climate consultant and show you how to do the analysis. Would you like to go to climate consultant right now? Please tell yes or no. I'll proceed.
Yes,
accordingly. Okay. Then I will open the climate consultant. So I have already installed it. So this is the version 6, which those who have downloaded recently would be having it. So the moment you open it, you'll see such a screen. And here, if you can notice, there's no location, latitude, longitude. It's all empty right now. So here they're telling you can download the weather data file, or some basic details are being mentioned here. We'll go in detail. So once we go next, there is a tab here in the bottom. Click next. Next. So you can either continue previous session or start a new project. I'll start a new project. So the moment you click on start a new project, there are two types of buildings. It can be residential or small non-residential. It's for a smaller building typology only. So I've taken residential, then again, whether you want imperial scale or metric scale, I'm using metric scale. And if you have a weather data downloaded, you can click on open existing EPW file and locate it from wherever you have downloaded it. Or you can download a new EPW weather file, and here you will get the link to go to the Energy Plus website where we saw it earlier. Okay, I'll repeat these things from the beginning. I'll close it and I'll start again so that those who haven't opened it yet will be able to follow. So you just open the climate consultant. There is a tab next. So here there are two options. Either you can proceed with the previous session or start a new project. So I'll click on a new project. And after you click on the project, you have to select the type of building and whether you want metric scale. So we can click on metric scale. And after that, then we saw it earlier. If you have already downloaded any EPW file earlier, you can just click on the second option. Open existing EPW weather file. If you have it downloaded somewhere, you can just go to it and locate it. So here I have one downloaded for Trivandrum. Or if you haven't downloaded it, either you can go to onebuilding.org, which I showed earlier, or if you click the download new EPW weather file here, click here, and then there is an option of install from weather data, which will redirect you to the weather data file where you can go to the particular region or particular space, location, and then download it. So you can download the EPW. When you click on the EPW, a file gets downloaded automatically. Is it clear till now? Okay. So now after downloading it, you can open it from the downloads or wherever you have downloaded it. Click on open, and I'll open the Bhopal one. So the moment you open it, you get a table like this, where all the weather data, whatever we saw in the CBE online tool, it can be seen as a table also here. So the moment earlier there was the location, latitude, longitude, everything in the top was empty. The moment you opened it, the location, the latitude, longitude of the area, and the data source, all these details are automatically updated, and even the units of all these things are given. So let us see how to visualize this. For each month, for each parameter, the monthly means are given. So here there are multiple comfort models. The California one is not applicable for our region. We can either use ASHRAE standard 55. There is a brief description given in all of these. So in ASHRAE standard 55, what they have given is the comfort model is based on dry bulb temperature, clothing level, metabolic activity, air velocity, humidity, and mean radiant temperature. Indoors, it is assumed that mean radiant temperature is close to dry bulb temperature. It's mostly in residential settings where people adapt clothing to match the season and even in higher air velocities. The last one is adaptive comfort model, where we mostly encounter where it is naturally ventilated spaces, where occupants can open and close windows. The thermal response will depend in part on the outdoor climate. If it is raining outside, we may open the window a little bit to let in the cool air inside. And it will have a wider comfort range. So let us consider the adaptive comfort model. Then click on next. So here with this, with current thing, there is no comfort currently. Let us see how do we do. Click on next. This is the actual weather data. Let us see first how is the weather data. So the temperature goes above 40 degrees in April and May. And in December, it goes up to even 10 degrees or even lesser than that. So here, this is the gray shaded one is the comfort zone. So this is the only time when people will feel comfortable. Either it is too hot or sometimes it's too cool. So the monthly diurnal averages, like whether the daytime temperature and nighttime temperature is changing. You can explore this in detail. All this weather data, when you try exploring based on your interest, you can explore to an extent whenever possible. So this gives the radiation ranges. Illumination data was not there in the weather file, so it's not there. Then the sky cover range, wind velocity range, ground temperature range, all these, then a combination of temperature and humidity is given. So you can see in the month of January, humidity is high, but the temperature is quite low, except during the daytime, in the afternoons. It's too cool. Whereas in July, it is almost, temperature is within the comfort range. Now let me show you the psychrometric chart, a basic of it. So here what we can see is only this time of the year is comfortable with adaptive comfort ventilation. Suppose we can change, if you want to incorporate certain other things as well as with adaptive comfort ventilation, 35% of the time you get comfort. But other than that, it is not comfortable. See, you can see 65% of the year it's not comfortable without much any intervention. So let us see what can be done now. So this will even generate certain sketches, more like a design guidelines, where you will get an idea of what can be done. So when you click on it, one thing is you can have a good ventilation. These are very basic sketches. I don't think it's worth exploring much on this, but someone who is just starting, someone who is in the initial years of BR, where you want to get an idea on what can be done for which climate, this can be used. Otherwise, this is a good, climate consultant is a good tool on exploring the climate data or visualizing the climate data. So here there are multiple things, whether you want to set criteria, whether you want to change the chart or the weather data summary, like this you can do. And also another thing what you can do is, if you want to explore more, there are total 8,760 hours in an year. So for any simulation, when you do, it simulates for this 8,760 hours. So if you want the data for each of these 8760 hours, you can even get it. So here what you can do is, there is something called as export weather data in the file, where you can click on it. If you are interested only in dry bulb temperature and maybe relative humidity, click on that, whatever parameter you want. You can click on hourly, export to CSV, or I'll click some data. The file is exported. Let me show you. See, for this climate, the dry bulb temperature and humidity. So here you can see, this is the first month, January. On the first day, on the first hour, you are having 19.6 degrees Celsius temperature and 66% humidity. Like this, up to 24 hours you get. So when you count this whole thing, this is for the first month, and after that you will start the second month, February. Like this, you get it for 8,760 hours. For each day of the year, each hour, what is the temperature and humidity as per the weather. Any doubts you have yet? Or any questions?
Now, this data can be uploaded in that Energy Plus website. Energy
This is
Plus.
already downloaded from Energy Plus website, right?
No, the other one you have shown. Like
I didn't get
CB,
it.
CBE climate one.
Yes, you can upload. There you need not have this Excel file itself. You can directly upload the EPW file to visualize it.
No, ma'am, you said
What
we
was
need to upload. We need to upload some CSV file to
you need
visualize.
not upload the CSV file. I will show you. See, here there is something called select weather file.
Yes,
But
ma'am.
you can directly drag and drop in the EPW file. What we
Okay,
have
or else you can select it here.
yes. Either you can select it here, or you can, if you have a specific place, you can directly drag and drop it here.
No, somewhere you have asked to upload a CSV file.
CSV file, I don't remember. That was for the comfort. That is, if we have measured something, if we have measured the temperature of a particular room, and this is the clothing of this person, this is the activity. Those values you can upload, and then you can get the comfort.
So we can refer these values to upload there.
No. This is the weather file. This is the weather data. What we will be doing for comfort assessment is, in this room, what is the temperature now? We are measuring it with a thermometer. So if you want to know if I'm comfortable at this temperature, to support it, you can upload this value and check whether you can be comfortable. That is
Thank you.
not a value of just temperature. It has all these: airspeed, humidity, metabolic rate, the personal factors of the person. Whether the person is sitting, whether what he's wearing, all those things are included in
Okay, thank you.
that. Okay.
Participants, if you have any query, any question, please ask the experts. If you want to discuss anything related to the expertise, so please ask.
Any output on this analysis, like designing this much U value of the wall is required?
That is done basically in the energy simulations or a simulation of a whole building after modeling it.
So this is this comes under modeling.
No, this doesn't come under modeling. This is just assessment tool. Modeling can be either done in Design Builder or it can be done in IES. There are so many softwares where you can do a building model, assign wall material, assign all the building properties, and then check.
This data is required for modeling, ma'am.
Weather data is required. The EPW file what we have downloaded is required for those simulations.
Okay, thank you.
Participants, if you have any query, anyone, if you have any query, please ask the experts. You want to discuss any your research area?
Somebody had asked my email ID. I'll just share it in the chat box.
Participants, if you have any question, then please, you are welcome. Otherwise, we are going to proceed further. So if you have any query, then please ask. Otherwise, we going to the end of the sessions parts. So, okay. So I'm on the behalf of organizing committee and all participants of the faculty of program, Smart Building Design. We extend the sincere gratitude to you, ma'am, about a highly informative sessions and your expert talk on the firstly the building healthy and comfortable and the hand-on session on the exploring thermal comfort and AIQ offered a valuable insights aspects of the indoor air quality and the smart and sustainable building designs. And we are truly appreciated that you discussed about the impact of air quality in the occupant health and the other productivities. And the second, the air quality measurement methods and the tools used as the AIQ in the real settings. And in additional, you are discussed and detailedly explained and demonstrates the tools such as EVE, thermal comforts tools, climate one building tools, and the use of climate consultant that is greatly enhanced our understanding and how to analyze the thermal comforts and climate data effectively. So these practical tools added immense value to the sessions and provide a clear path to apply the theoretical knowledge and the real world scenarios. So the engaging examples and live demonstrations and the practical recommendation made by the session especially impactful. And we are grateful for your for the opportunity to learn from your expertise and experience. So thank you once again, ma'am, for your valuable contribution in this FDP program. And surely we look forward more in futures. futures. So thank you. And with this we going to close the session. So all participants, thank you, all of you. And finally, we will at the last session at 4 o'clock. Thank you, everyone.
Sir, can you have access to the these presentations?
Sir, the presentation will be collected from the experts. If they are willing, all willing, we will share the link of the all the PPTs and the videos at the last day of the FDP program. Even video link we will be shared by today and tomorrow's, as we download from one by one, day by day. We going to update in the Google Drives.
Thank you, sir.